The universe is an endless expanse of wonder, filled with mysteries so profound they blur the line between science and science fiction. Picture this: somewhere out there, drifting through the infinite void, are objects and phenomena so bizarre they defy everything we think we know about reality. From stars that shouldn't exist to cosmic whispers with no clear origin, the cosmos holds secrets that even the brightest minds struggle to explain. What if I told you that some of these discoveries are so strange, they've left astronomers scratching their heads for decades? Today, we're setting off on a journey to uncover 30 of the most mind-bending, spine-tingling enigmas ever found in the universe, each one challenging our very understanding of space, time, and the fabric of existence itself. Think about the last time you looked up at the night sky and felt that humbling sense of awe. Now imagine that same sky hiding something far weirder than you could ever dream up, a place where the rules of physics seem to bend, where celestial objects behave in ways that shouldn't be possible. Some of these cosmic oddities are so extreme, they sound like they're ripped straight from the pages of a fantasy novel. Take, for example, a star that's older than the universe itself, or a galaxy with no dark matter, discoveries that force us to question everything we thought was set in stone. And that's just the beginning. This isn't just a list of strange space facts, it's an invitation to explore the edges of human knowledge, where the known universe starts to unravel into the inexplicable. What makes these phenomena so extraordinary isn't just their weirdness, it's what they reveal about how much we still have left to discover. Every oddity we encounter is a clue, a puzzle piece in the grand mystery of existence. So if you're ready to have your mind stretched to its limits, to peer into the cosmic unknown and come face to face with the truly unexplainable, then buckle up. Because what we're about to uncover will leave you questioning everything you thought you knew about the universe, and maybe even reality itself. The Boötes Void is one of the most baffling cosmic mysteries ever discovered, an unimaginably vast stretch of space so empty it feels like the universe forgot to fill it in. Picture a region nearly 330 million light-years across, where galaxies should be scattered like flickering streetlights in a city. Instead, you'd find only darkness, a cosmic desert so barren that astronomers call it the Great Nothing. To put that into perspective, if our Milky Way were placed at the center of this void, humanity might not have even known other galaxies existed until the 1960s. What makes this emptiness so unsettling is that it defies everything we understand about how the universe should look. According to our best cosmological models, matter should be spread relatively evenly across space, like a sponge with bubbles but no gaping holes. Yet the Boötes Void is more like a bottomless pit, less than 10% as dense as the rest of the cosmos. Some scientists have joked that it looks like someone took a giant cosmic vacuum and sucked away almost everything inside. So how did this void come to be? One leading theory blames quantum fluctuations from the earliest moments of the Big Bang, where tiny irregularities in energy could have stretched into these staggering voids over billions of years. Others propose something even wilder, that advanced civilizations far beyond our own might have harnessed unfathomable energy to reshape entire swaths of the universe, leaving behind these eerie blank spots. And then there are those who wonder if the void isn't empty at all, just filled with something we can't yet detect, like dark energy taken to an extreme. Whatever the explanation, the Boötes Void forces us to question whether we truly understand the rules of cosmic architecture. It's a humbling reminder that even in a universe teeming with galaxies, stars, and planets, there are still places where the ordinary laws seem to break down, leaving us staring into the abyss, wondering what else might be hiding in the dark. Rising from the heart of our galaxy like twin titans of energy, the Fermi Bubbles are colossal structures so immense they dwarf the entire Milky Way itself. Stretching 25,000 light-years above and below the galactic center, these gargantuan lobes glow with high-energy gamma rays, a silent testament to some cataclysmic event that occurred millions of years ago. Discovered in 2010 by NASA, a Fermi Gamma-Ray Space Telescope, these bubbles weren't spotted earlier because they're invisible to optical telescopes. Instead, they reveal themselves only through the faint whisper of gamma radiation, like cosmic fingerprints left behind by an unimaginable explosion. What could have created such monumental structures? One leading theory points to our galaxy's supermassive black hole, Sagittarius, a star. Imagine a feeding frenzy of cosmic proportions. A black hole devouring vast amounts of matter until it literally burps out twin jets of energy at near light speed. These jets could have punched through the galaxy's gas, carving out the bubbles we see today. But here's where it gets even stranger. The energy required to create these bubbles would have been staggering, equivalent to hundreds of supernovae exploding simultaneously. That kind of violence would have lit up the galactic center like a beacon across the universe. Yet there's another, even more exotic possibility: dark matter. Some scientists speculate that these bubbles might be evidence of dark matter particles colliding and annihilating one another in a slow, cosmic fireworks display. If true, it would be our first real glimpse into the invisible scaffolding holding galaxies together. But skeptics argue the energy signatures don't quite match, leaving the mystery wide open. The eerie part: whatever created the Fermi bubbles wasn't a one-time event. Similar structures have been spotted in other galaxies, suggesting this might be a universal phase galaxies go through, a violent adolescence where supermassive black holes reshape their surroundings in bursts of unimaginable power. For us, it's a front-row seat to the Milky Way's hidden past, a reminder that even our familiar galactic home has secrets buried in its history. And as we stare at those faint gamma-ray outlines, one question lingers: what else is lurking in the shadows of our own galaxy, waiting to be discovered? The Red Rectangle Nebula is one of the most geometrically perfect structures ever glimpsed in the cosmos, a celestial masterpiece so precise, it looks like it was drawn with a cosmic ruler. Imagine two glowing cones of gas and dust, stacked base to base to form an almost flawless hourglass shape, then encased within a series of nested red rectangles that give this nebula its name. At the heart of this spectacle sits HD 44179, a dying star in its final act, shedding layers of material into space like a cosmic matryoshka doll. But unlike the chaotic, swirling death throes of most stars, this one is creating something eerily symmetrical, a puzzle that defies the usual randomness of stellar evolution. What makes this nebula so unusual isn't just its shape, it's the weirdly artificial precision of it all. Most planetary nebulae, the glowing remnants of dying stars, resemble wispy clouds or tangled bubbles, their forms sculpted by turbulent stellar winds and magnetic chaos. But the red rectangle's sharp edges and exact angles suggest something far more controlled. Some astronomers theorize that the central star is encircled by an immense, dense disk of dust, forcing its expelled material to funnel outward in two opposing jets, creating that unmistakable X shape. Yet even this explanation doesn't fully account for the nested layers like ripples frozen in time, or the vivid red hue caused by mysterious hydrocarbon molecules that glow under ultraviolet light. Then there's the question of scale. The red rectangle spans nearly a third of a light year, meaning its structure has held its rigid form for thousands of years, resisting the forces that should have blurred it into asymmetry. Some researchers speculate that unseen planets or companion stars might be shaping the outflow, acting like cosmic sculptors. Others wonder if we're witnessing a rare phase of stellar death, a fleeting moment of order before chaos takes over. But perhaps the most tantalizing idea is that we're seeing the universe play a trick on us, a perfect alignment of angles and perspectives that only looks rectangular from our vantage point. Whatever the truth, the Red Rectangle Nebula stands as a cosmic anomaly, a reminder that even in the cold, indifferent vastness of space, nature can produce structures so precise they feel almost intentional. It challenges our assumptions about how stars die and how beauty emerges from destruction, leaving us to marvel at a universe that, even in its final breaths, can still surprise us with geometry worthy of an artist's hand. Hovering silently in Earth's orbit like a relic from another age, the so-called Black Knight satellite has fueled decades of wild speculation and conspiracy theories. Some claim it's an alien probe watching us for thousands of years, a piece of extraterrestrial technology left behind by visitors who came long before human civilization. Others insist it's evidence of a lost advanced human society, a forgotten satellite launched into space millennia ago. The stories around it read like science fiction. Radio signals picked up by Nikola Tesla in the 1890s, mysterious photographs from early space missions, and even whispers of government cover-ups. But what's really lurking up there, the truth, as it often is far stranger than fiction, but not in the way conspiracy theorists might hope. The Black Knight legend is a patchwork of misunderstandings, misidentified objects, and a dash of imagination. One of the most famous sightings came in 1960 when newspapers reported an unknown satellite in polar orbit, a feat impossible for human technology at the time. The excitement faded when scientists realized it was likely just a piece of debris from a recent launch, tumbling unpredictably through space. Then there are the eerie images from NASA missions, often cited as proof, like a 1998 photo of what appears to be a dark, angular object floating near the International Space Station. In reality, it was a thermal blanket lost during a spacewalk, drifting harmlessly in the void. Even the name Black Knight is a mystery wrapped in myth. No official records from NASA or other space agencies reference such an object, and the term seems to have emerged from speculative retellings of old radio interference incidents. But here's where it gets interesting. While the Black Knight itself might not exist, Earth's orbit is cluttered with real relics of human exploration, spent rocket stages, dead satellites, and even lost tools from astronauts. These objects, drifting for decades, can appear bizarre when caught in the right light, fueling the illusion of something more sinister. So why does the myth persist? Perhaps because the idea of an ancient watcher in the sky taps into something deep in human psychology, a longing for connection with the unknown, or a suspicion that we're not alone. Or maybe it's just a testament to how easily the vast, silent expanse of space can play tricks on our perception, turning mundane debris into legends. Either way, the Black Knight serves as a reminder that the line between mystery and reality is often thinner than we think, and that sometimes the most compelling stories are the ones we create ourselves. On the sweltering night of August 15, 1977, a radio telescope in Delaware, Ohio, picked up something impossible to ignore, a signal so powerful, so bizarre, that it sent shockwaves through the world of astronomy. For 72 seconds, a burst of electromagnetic noise blared from the constellation Sagittarius, hitting a frequency that scientists had long theorized might be used by extraterrestrial civilizations. The signal was 30 times stronger than the background noise of space, and when astronomer Jerry Amon saw the computer printout, he famously scrawled, "Wow," in red ink, giving the mystery its iconic name. Decades later, we still don't know what caused it. What makes the wow signal so tantalizing is how perfectly it fits the profile of an intentional interstellar broadcast. The frequency, 1420 MHz, sits in a quiet zone of the radio spectrum, a band where natural cosmic noise is minimal, making it ideal for long-distance communication. The signal also exhibited a telltale rise and fall in intensity, matching what you'd expect if it originated from a fixed point in space and drifted past Earth due to our planet's rotation. But here's the catch: despite countless follow-up scans, the signal never repeated. It vanished as suddenly as it appeared, leaving behind only that cryptic printout and a mountain of unanswered questions. Could it have been a message from an alien civilization? Skeptics argue that more mundane explanations exist. Some suggest it might have been a rogue comet, releasing hydrogen gas that emitted a brief but intense radio burst. Others propose it was an undiscovered natural phenomenon, a cosmic hiccup never before observed. Even interference from a passing satellite or secret military project can't be ruled out. But none of these theories fully explain why the signal matched so precisely with what we'd expect from an engineered transmission, or why we've never detected anything like it since. The WOW signal's legacy isn't just about the search for extraterrestrial intelligence. It's a stark reminder of how little we truly understand about the universe's radio soundtrack. For those 72 seconds, the cosmos seemed to whisper something deliberate, something meant to be heard. Whether it was a cosmic coincidence or a greeting from the stars remains one of astronomy's greatest unsolved riddles. And until we find another like it, that single, fleeting burst will keep us staring at the sky, wondering if we were ever meant to hear it at all. Deep in the constellation Serpens, a dead star spins at dizzying speeds, dragging a world unlike any other through the void with it. Meet PSRJ 1719-1438b, a planet so dense, so dazzlingly strange that astronomers have dubbed it the Diamond Planet. Imagine a world where the very ground beneath your feet isn't rock or ice, but crystallized carbon compressed into something harder than any gemstone on Earth. This isn't science fiction, it's a remnant of cosmic violence, the shattered core of a once mighty star crushed into something utterly alien. What makes this planet so extraordinary is its origin story. Most planets form from the dusty debris swirling around young stars, but this one is different. Scientists believe it started its life as a white dwarf, the smoldering corpse of a sun-like star that exhausted its nuclear fuel. Normally, white dwarfs slowly fade into darkness, but this one had a fate far more dramatic. Drawn into the gravitational grip of a nearby pulsar, a rapidly spinning neutron star that beams radiation like a cosmic lighthouse, the white dwarf was stripped to its core. Over eons, the pulsar's relentless pull siphoned away its outer layers, leaving behind only the dense, diamond-rich heart. The numbers behind this world are staggering. Though it's only about 5 times the size of Earth, the Diamond Planet packs a mass greater than Jupiter, making it one of the densest objects ever discovered. That incredible heft comes from its composition: carbon compressed under unimaginable pressure, forced into a crystalline structure that could span thousands of miles. If you could stand on its surface, which you couldn't, given the crushing gravity and deadly radiation, the entire landscape might glitter like a fractured jewel under the pulsar's eerie glow. But here's the twist: this planet shouldn't exist at all. The conditions required to create such an object are so extreme, so finely balanced between destruction and preservation, that finding one feels like stumbling upon a cosmic unicorn. Some researchers speculate there might be others lurking in the galaxy, remnants of similar stellar encounters hidden in the noise of deep space. Others wonder if the Diamond Planet is a glimpse into a far future Earth, a morbid preview of what might happen if our own world were ever captured by a runaway neutron star. The real magic of this discovery isn't just the allure of a planet made of diamond. It's the reminder that the universe is a master of alchemy, capable of transforming the ordinary into the extraordinary under the right conditions. In the death throes of stars and the chaos of gravitational tides, even something as simple as carbon can become a celestial masterpiece, a glittering tombstone for a star that refused to fade quietly into the dark. Among the countless stars dotting our galaxy, one stands out not for its brilliance, but for its bizarre behavior: KIC 8462852, better known as Tabby's star. Named after astronomer Tabitha Boyajian, who first brought its anomalies to light, this unassuming star, located 1,400 light-years away in the constellation Cygnus, has baffled scientists with its unpredictable flickering. Unlike typical stars, which dim in regular, predictable patterns when planets pass in front of them, Tabby's star plunges into darkness erratically, sometimes by as much as 22%, an amount impossible to explain with ordinary planetary transits. The first whispers of something unusual came in 2015 when citizen scientists combing through data from NASA's Kepler Space Telescope flagged the star's bizarre light curve. Instead of the smooth, symmetrical dips caused by orbiting planets, the star's brightness dropped in jagged, irregular intervals, almost as if something colossal and uneven were passing in front of it. The strangest part, these dips lasted for days, even weeks, suggesting whatever was blocking the light wasn't a simple spherical object, but something far more complex. This led to one of the most provocative theories in modern astronomy: the idea that an advanced alien civilization might have built a Dyson swarm, a massive array of energy-harvesting megastructures encircling the star. The concept, first proposed by physicist Freeman Dyson in the 1960s, suggests that a sufficiently advanced society could construct solar collectors on an unimaginable scale, capturing the star's energy and causing the erratic dimming we observed. For a brief, electrifying moment, humanity wondered if we'd stumbled onto evidence of extraterrestrial engineering. Yet as tantalizing as the alien hypothesis was, science demanded a more grounded explanation. Further observations revealed that the dimming wasn't uniform across all wavelengths, a key clue. If solid structures were blocking the light, the dimming would be consistent. Instead, the star faded more in blue light than in red, pointing toward something diffuse like dust. Recent studies now suggest that Tabby's star might be surrounded by vast clouds of fine, uneven debris, possibly the remnants of a shattered planet or comet swarm, torn apart by the star's gravity and left to drift in chaotic orbits. But even this explanation leaves puzzles unsolved. The dust would need to be replenished constantly to account for the long-term dimming, and the star's gradual fading over the past century defies typical stellar behavior. Some researchers speculate the star might be recovering from a cataclysmic collision, while others wonder if we're witnessing a rare phase of stellar evolution, one where a star's own activity kicks up immense dust clouds. What makes Tabby's star so compelling isn't just the mystery, it's the reminder that even in an age of advanced telescopes and AI-driven analysis, the universe can still serve up phenomena that push the limits of our imagination. Whether it's dust, debris, or something even more extraordinary, this star challenges us to keep looking, keep questioning, and stay open to the possibility that the cosmos still has secrets we've only begun to uncover. NGC 1277, known as the Cannibal Galaxy, is a cosmic relic frozen in time, a galactic time capsule that hasn't formed a single new star in over 10 billion years. Locked away in the constellation Perseus, this ancient anomaly offers us a rare, undisturbed glimpse into what the universe looked like when galaxies were just taking shape. Unlike the Milky Way, where stars are born and die in a continuous cycle, this galaxy is like a museum piece, preserving its primordial state with eerie perfection. The secret to its unchanging nature lies in its violent past. NGC 1277 is what astronomers call a relic galaxy, a term reserved for rare celestial survivors that avoided the usual mergers and collisions that reshape most galaxies over time. But here's the twist: it didn't stay pristine by staying lonely. Instead, it gorged itself on neighboring galaxies early in its life, growing so massive and so quickly that it burned through its star-forming gas long before the universe hit middle age. Imagine a cosmic black hole vacuuming up everything around it, then sitting bloated and dormant, its appetite exhausted. That's the Cannibal Galaxy, a predator that ate its fill and then fell silent. What makes this galaxy so valuable to scientists isn't just its age, but its untouched composition. Most galaxies from this era have been scrambled by later collisions, their original structures lost to time. But NGC 1277 stars remain packed tightly together, their orbits unchanged since they first formed. Studying them is like cracking open a fossil and finding the DNA of the early universe still intact. The stars themselves are bizarre, older, redder, and richer in heavy metals than expected, hinting at a star-forming frenzy that defies current models of galactic evolution. Yet the biggest mystery isn't why this galaxy stopped evolving, it's why others didn't. In a universe where change is the only constant, how did NGC 1277 escape the forces that reshaped its peers? Some theories suggest its location in a dense galaxy cluster shielded it from disturbances, while others propose its supermassive black hole, unusually large even for its size, might have choked off star formation early on. But the truth might be even simpler. Perhaps it's just a cosmic fluke, a reminder that the universe doesn't follow tidy rules. For astronomers, this galaxy is more than a curiosity. It's a key to unlocking secrets about how galaxies were born. Its frozen state lets us test theories about the early universe with unparalleled precision, offering clues about why some galaxies thrive while others stagnate. And as we peer deeper into its ancient light, one haunting question lingers. Are there others like it out there, equally untouched, waiting to tell their stories? In a cosmos brimming with motion and chaos, the Cannibal Galaxy stands as a testament to the power of stillness and the secrets it can keep. In the quiet void between galaxies, astronomers recently stumbled upon something that defies explanation: enormous, perfect rings of radio energy, each spanning hundreds of thousands of light years. Discovered in 2020 using Australia's ASCAP telescope, these odd radio circles, or ORC, appear as ghostly halos on radio wave images, invisible to optical telescopes. They don't match anything we've seen before, not supernova remnants, not distant galaxies, not even the aftermath of black hole collisions. They're just there, massive, mysterious, and utterly perplexing. What makes these rings so baffling is their sheer scale and symmetry. Imagine a structure so vast it could swallow our entire Milky Way, yet so precise it looks like a ripple frozen in time. The leading theory suggests they might be shockwaves from some cataclysmic event, perhaps two galaxies colliding with such force that the resulting energy burst created a spherical tsunami, visible only in radio waves. But here's the catch: most ORCs don't have a visible galaxy at their center, leaving scientists scratching their heads about what could have triggered such a titanic release of energy. Then there's the wormhole hypothesis, an idea so wild it sounds straight out of science fiction. Some researchers speculate these rings could be the imprint of a wormhole's mouth, a tunnel through space-time so immense it warps the fabric of the universe around it. According to this theory, the radio emissions might be caused by particles accelerated to near light speed as they spiral into the wormhole's gravitational whirlpool. It's a long shot, but in a universe where black holes once seemed impossible, could wormholes leave behind similar cosmic fingerprints? Yet another possibility ties ORCs to fast radio bursts, those mysterious, milliseconds-long energy pulses from deep space. If a particularly violent burst passed through a cloud of galactic gas, it might heat the material into a temporary bubble, glowing faintly in radio frequencies before vanishing. The problem: ORCs persist for millions of years, far longer than any known transient event. The truth is, ORCs challenge our understanding of how energy behaves on cosmic scales. They're reminders that even with our most advanced telescopes, the universe still holds phenomena we can't yet categorize, let alone explain. Whether they're echoes of ancient collisions, portals to other dimensions, or something beyond our current physics, one thing is certain: the deeper we look into the cosmos, the more it surprises us with questions we never thought to ask. The universe is supposed to expand evenly in all directions, a predictable, uniform stretch of space and time. But in 2008, astronomers made a discovery that shattered this assumption. Hundreds of galaxy clusters, each containing thousands of galaxies, were all streaming in the same direction at breakneck speeds. This bizarre motion, dubbed the dark flow, suggests something massive, something beyond the edge of our observable universe, is pulling them like a cosmic magnet. And if true, it could rewrite our understanding of reality itself. The sheer scale of this motion is staggering. These galaxy clusters aren't just drifting, they're hurtling at speeds exceeding 2 million miles per hour, all toward a single point in space near the constellations Centaurus and Vela. What's weirder, this movement defies the gravitational influence of every known structure in our universe. Superclusters, black holes, even the Great Attractor, a massive concentration of galaxies once thought to be the universe's most powerful gravitational pull. None of them can account for this coordinated rush. That leaves only two possibilities. Either something unimaginably vast lurks in the unobservable darkness beyond our cosmic horizon, or our measurements are catastrophically wrong. The leading and most mind-bending theory is that the dark flow might be evidence of other universes. Imagine our cosmos as a bubble in an infinite foam of other bubble universes, each with its own physical laws. If one of these neighboring bubbles brushed against ours during the Big Bang, the gravitational tug of its matter could still be dragging our galaxy clusters toward it, like tides pulled by an invisible moon. This idea, rooted in multiverse theories, suggests the dark flow might be our first glimpse into a reality beyond our own, but skeptics aren't convinced. Some argue the data could be skewed by instrument errors or local anomalies we haven't accounted for. Others propose that peculiarities in the cosmic microwave background, the afterglow of the Big Bang, might be creating an illusion of motion where none exists. After all, measuring the movement of galaxy clusters across billions of light-years isn't simple, and even tiny miscalculations could produce phantom signals. Yet the dark flow persists in newer studies, refusing to fade into statistical noise. If it's real, the implications are profound. It would mean our universe isn't just lopsided, it's connected to something greater, something beyond the limits of our telescopes. And that raises a haunting question. What else is out there, hidden in the dark, shaping the fate of everything we can see? Whether it's a flaw in our data or a crack in the doorway to the multiverse, one thing is certain: the dark flow reminds us that the universe still has secrets we've barely begun to uncover. Floating like a celestial bullseye in the vastness of space, Hoag's object is a galaxy so perfectly ring-shaped it looks like it was designed by an artist rather than the chaotic forces of the cosmos. Discovered in 1950 by astronomer Art Hoag, this stunning structure features a golden yellow core of ancient stars surrounded by a luminous sapphire blue ring of younger hot stars, a cosmic jewel box suspended in the void. What makes it so mesmerizing isn't just its beauty, but the fact that it defies nearly everything we know about how galaxies form. Most galaxies fall into familiar categories: spirals like the Milky Way, ellipticals, or irregular blobs. But Hoag's object belongs to an exclusive club of ring galaxies with a twist. Its core and ring are almost perfectly detached, separated by a dark, starless gap that stretches over 75,000 light-years. The leading theory suggests this bizarre structure was forged by a cataclysmic collision billions of years ago, when a smaller galaxy punched straight through the heart of a larger one. Picture the cosmic equivalent of throwing a rock into a pond. The gravitational shockwave would send stars and gas rippling outward, leaving behind a dense central core and a glittering ring of displaced material. Yet even this explanation leaves gaps. For one, there's no visible remnant of the intruder galaxy, no telltale debris cloud or distorted core to confirm the collision. Some researchers argue the ring might have formed from internal instabilities, with the galaxy's own gas collapsing into a starburst wave that propagated outward. Others propose an even wilder idea, that Hoag's object is the result of a rare peanut shell effect where the galaxy's central bar, a dense lane of stars, collapsed and ejected its outer layers into a perfect circle. Then there's the mystery of scale. The ring is almost impossibly symmetrical, with no signs of warping or clumping despite spanning a distance larger than our entire Milky Way. This level of precision is unheard of in a universe where gravity and turbulence usually create messy, uneven structures. Adding to the intrigue, astronomers have spotted at least one other tiny ring galaxy floating nearby, a possible cosmic sibling hinting that this region of space might be a factory for these peculiar formations. What makes Hoag's object so captivating isn't just its strangeness, but what it represents: a snapshot of galactic evolution so rare, it's like finding a perfectly preserved fossil in a landslide. It challenges our textbooks, forcing us to reconsider how galaxies grow, collide, and reshape themselves over eons. And as we gaze at its flawless ring, we're left to wonder, is this the aftermath of a violent accident or the signature of a process we've yet to understand? In a universe filled with chaos, Hoag's object stands as a serene enigma, a reminder that even the laws of physics can sometimes produce something breathtakingly perfect. The Hercules Corona Borealis Great Wall isn't just a cosmic structure, it's a cosmic anomaly so vast, it challenges the very foundations of modern cosmology. Stretching an almost unimaginable 10 billion light-years across, this galaxy filament holds the title of the largest known structure in the observable universe. To put that into perspective, if you could travel at the speed of light, it would take you longer to cross this wall than the current age of our solar system. This isn't just a cluster of galaxies, it's a sprawling metropolis of stars, gas, and dark matter, woven into a tapestry so immense it defies explanation. What makes this structure so unsettling isn't just its size, it's the fact that it shouldn't exist at all. According to the cosmological principle, a cornerstone of modern astrophysics, matter in the universe should be distributed evenly on the largest scales. In other words, if you zoom out far enough, the cosmos should look roughly the same in every direction, like foam in a bubble bath. Yet the Hercules Corona Borealis Great Wall shatters that assumption. Its sheer scale suggests a level of clustering that shouldn't be possible under our current understanding of how the universe evolved after the Big Bang. Scientists first stumbled upon this behemoth in 2013 while mapping gamma-ray bursts, the brightest explosions in the universe often linked to the deaths of massive stars. These bursts acted like cosmic breadcrumbs, revealing an eerie pattern, an unusually high concentration of galaxies spanning a third of the visible sky. The odds of such a structure forming naturally are astronomically low, raising the unsettling possibility that our models of cosmic evolution might be missing something fundamental. Could this wall be evidence of exotic physics? Some theorists speculate that quantum fluctuations in the early universe, magnified by inflation, might have created ultra-dense regions that later collapsed into these titanic filaments. Others wonder if it's a sign of something even stranger, a wrinkle in spacetime itself, a relic from before the Big Bang, or even a gravitational echo from a collision with another universe. But perhaps the most humbling idea is that we're seeing the limits of our own perception. The Hercules Corona Borealis Great Wall lies at the edge of the observable universe, where light has traveled nearly the entire age of existence to reach us. Beyond it, there could be structures even larger, stretching into the infinite dark, realms so vast they redefine what we thought possible. Whether it's a flaw in our theories or a glimpse of something deeper, one thing is certain: this cosmic wall forces us to confront how little we truly understand about the universe's grand design. Most stars don't survive a supernova. They either explode into oblivion or collapse into black holes, vanishing from the cosmic stage. But deep in the constellation Eridanus, astronomers found something that defies the rules, a star that refused to die. SN 2012Z, a so-called Type IX supernova, should have annihilated its progenitor star entirely. Instead, the star lingered, scarred but alive, earning it the eerie nickname the zombie star. This isn't just a cosmic oddity, It's a crack in our understanding of how stars die, revealing that the universe's most violent explosions might sometimes leave survivors. What makes this star so baffling is the nature of its explosion. Typical type Ia supernovas occur when white dwarfs, the dense cores of dead stars, steal so much mass from a companion that they cross a critical threshold and detonate in a thermonuclear fireball. These blasts are so uniform, astronomers use them as cosmic yardsticks to measure the universe's expansion. But type IX supernovas are different. They're fainter, slower, and messier, like a firework that sputters instead of erupting. In the case of SN 2012Z, the explosion was so weak that the white dwarf didn't fully disintegrate. Instead, it ejected a fraction of its material and staggered onward, a charred remnant of its former self. The implications ripple far beyond one star. If some white dwarfs can survive supernovas, it means these explosions aren't always the end. They might be a violent phase in a star's evolution. Imagine a stellar phoenix repeatedly erupting and rebuilding itself over millennia. This could explain other cosmic mysteries, like why some supernova remnants lack the expected debris or why certain white dwarfs appear older than the universe itself. It also raises a tantalizing question: could our own sun, billions of years from now, undergo a partial explosion and linger as a zombie version of itself? But the real puzzle is how these stars cheat death. One theory suggests the explosion might begin deep inside the white dwarf, fizzling before it reaches the surface. Another proposes that the companion star, usually a red giant, acts as a shock absorber, soaking up some of the blast's fury. Or perhaps the white dwarf's rotation or magnetic field disrupts the detonation, leaving it incomplete. Whatever the answer, these zombie stars force us to rewrite the stellar rulebook, proving that even in death, the universe has surprises up its sleeve. The discovery of SN 2012Z's survivor isn't just a curiosity, it's a glimpse into a hidden chapter of stellar life cycles. For decades, we thought supernovas were finales. Now we know some stars can endure them, twisted and battered but still burning. In the grand cosmic drama, these undead stars remind us that the universe is far stranger, far more resilient than we ever imagined. And as we search the skies for more of their kind, one thing is certain: the line between life and death in the cosmos is blurrier than we thought. Tucked away in the constellation Libra, a faint bluish star flickers with a secret that has shaken modern cosmology to its core. Known officially as HD 140283, but more poetically as the Methuselah star, this ancient relic carries an age estimate of 14.5 billion years, a number that sent shockwaves through the scientific community. Why? Because our current best calculations place the universe itself at just 13.8 billion years old. For a star to exist before the cosmos it inhabits isn't just unlikely, it's impossible. Or at least it should be. Discovered over a century ago but only recently studied in detail, the Methuselah star is a cosmic paradox. Its composition, rich in hydrogen and helium but nearly devoid of heavier elements, marks it as a member of population 2, the second generation of stars born after the Big Bang. These primordial stars are rare time capsules, forged from almost pure primordial gas before supernova seeded the universe with metals. But even among its peers, Methuselah stands out. Its extreme age was initially calculated based on its dimness, temperature, and lack of metals, all clues that pointed to a star nearing the end of its life after an unfathomably long burn. So how could it be older than the universe? The answer, as is often the case in science, lies in the margins of error. Revised measurements using data from the Hubble Space Telescope tightened the star's age estimate to around 14 billion years, with an uncertainty of plus or minus 800 million. That overlap with the universe's age eases the tension slightly, but the paradox isn't entirely resolved. What's more intriguing is how this star has forced us to refine not just stellar aging techniques, but our very understanding of cosmic chronology. One key factor is the star's oxygen content. initially overlooked, newer studies revealed slightly higher oxygen levels than expected for such an ancient star. Since oxygen could only have been forged in earlier supernova, this tiny adjustment shaves about 500 million years off Methuselah's original age estimate. Then there's the star's motion. It's hurtling through the Milky Way at over 800,000 miles per hour, suggesting it may have been ejected from a long-vanished dwarf galaxy, further complicating its history. But the Methuselah star's true legacy isn't just about recalibrating a number, it's about challenging our confidence in cosmic timelines. If our measurements are this uncertain for a single star, what does that say about our broader assumptions? Some theorists speculate this could hint at flaws in our models of cosmic inflation, the rapid expansion of the universe moments after the Big Bang. Others wonder if dark energy's influence on the universe's expansion rate might need reevaluation. And then there's the radical possibility that our universe isn't the first but one in a cycle of cosmic rebirths, with Methuselah as a relic from a previous iteration. Every time we look at this ancient star, it teaches us something new, not just about the lifespan of stars, but about humility in the face of the unknown. It reminds us that the universe's history is written in layers, and we're only just beginning to decipher them. Whether it's a cosmic accounting error or a clue to deeper truths, the Methuselah star stands as a luminous question mark in the sky, silently urging us to keep looking, keep questioning, and never assume we've got it all figured out. Deep in the heart of our Milky Way, a sleeping giant occasionally stirs, unleashing tsunamis of energy so powerful they could rewrite the history of life across the galaxy. These are galactic superwaves, theoretical eruptions of gamma rays and cosmic rays believed to emanate from the supermassive black hole at our galaxy's core. Unlike the predictable rhythms of supernova or solar flares, these events are thought to arrive in catastrophic pulses, flooding the Milky Way with radiation capable of stripping atmospheres, triggering mass extinctions, and sterilizing entire planets. And the most unsettling part, some scientists suspect Earth may have already weathered one of these invisible apocalypses, with another potentially lurking in our cosmic future. The theory hinges on Sagittarius, a star, the 4 million solar mass black hole anchoring our galaxy. While relatively quiet now, geological and astrophysical clues suggest it wasn't always so calm. In the late 1970s, physicist Paul Laviolette proposed that our central black hole might undergo periodic, active phases, where it devours vast amounts of matter and belches out cones of high-energy particles. These jets wouldn't travel in neat lines instead. They'd snowplow through interstellar gas, creating shock waves that accelerate particles to near light speed. The result, a rolling front of radiation that could bathe the galaxy in deadly rays for thousands of years. Evidence for past superwaves comes from surprising places. Ice cores drilled from Antarctica reveal spikes in radioactive isotopes like beryllium-10 and chlorine-36, markers of intense cosmic ray bombardment around 12,000 years ago, coinciding with the Younger Dryas period. This era saw abrupt climate shifts, megafauna extinctions, and the collapse of early human civilizations like the Clovis culture. While mainstream science often attributes these events to comet impacts or solar flares, superwave proponents argue the timing and global scale better fit a galactic-scale radiation storm. Even more provocative are fossil records showing sudden mutations in ancient plant spores, damage consistent with extreme radiation exposure. But what about the future? If superwaves are real, their periodicity remains unknown. Some models suggest they might recur every 10 to 15,000 years, while others argue they're far rarer, tied to the Milky Way's 50 million-year oscillation through the denser galactic plane. The latter scenario would mean Earth is currently in a quiet zone, shielded by our position away from the core. Yet with Sagittarius, a star showing flickers of activity in recent decades, including mysterious X-ray flares and a puzzling brightening of surrounding gas, no one can say for certain when the next superwave might arrive. The scariest aspect isn't just the radiation itself, but its secondary effects. A full-scale superwave could rip apart Earth's ozone layer, exposing life to lethal UV levels from our own sun. Cosmic rays might seed dense cloud cover, triggering an ice age, and high-energy particles colliding with our atmosphere could spawn cascades of muons, heavy subatomic particles capable of penetrating deep underground, meaning even shielded bunkers might not guarantee survival. It's a sobering reminder that extinction-level threats don't always come from nearby supernova or asteroids. Sometimes they're woven into the very fabric of our galaxy. Yet there's a twist. Superwaves might also be cosmic catalysts. Some researchers speculate these events could have jump-started life by irradiating primordial molecules, forcing them into complex organic structures. Others suggest periodic sterilizations could explain the Fermi paradox, the eerie silence of the universe, by resetting intelligent civilizations just as they begin to flourish. Whether destroyers or unlikely architects of complexity, galactic superwaves force us to confront a humbling truth. Our fate may be tied to cycles far grander than we've ever imagined. And as we peer into the abyss of the Milky Way's core, one question lingers: are we living in the calm between storms? Most comets follow predictable paths, looping in from the frozen edges of the solar system before flaring up in brilliant tails as they near the sun. Asteroids, on the other hand, are the silent rocks of the inner system, tracing stable orbits between Mars and Jupiter without so much as a shimmer of activity. But in 1996, astronomers stumbled upon an object that defied this neat cosmic categorization, a strange hybrid now known as the Elst-Pizarro comet. At first glance, it looks like any other asteroid nestled in the main belt between Mars and Jupiter. Yet every now and then, it does something utterly unexpected. It wakes up, sprouting a ghostly tail of dust like a comet in full display. This odd behavior makes Elst-Pizarro a member of an exclusive club, the main belt comets, a rare class of objects that blur the line between asteroids and comets. Unlike traditional comets, which originate in the Kuiper belt or Oort cloud, these enigmatic bodies share orbits with asteroids but occasionally erupt with comet-like activity. The puzzle isn't just why they behave this way, it's how they got there in the first place. One leading theory suggests they might be refugees from the outer solar system, flung inward by gravitational encounters with Jupiter and stranded in the asteroid belt. Another possibility is that they're remnants of ancient collisions, fragments of larger bodies that once harbored subsurface ice, now exposed and venting sporadic plumes of vaporized material into space. What makes Elst-Pizarro particularly fascinating is the rhythm of its outbursts. Unlike comets that flare predictably when nearing the sun, this object seems to activate on its own schedule. Observations reveal it has erupted multiple times since its discovery, sometimes even when it's farthest from the sun's warmth. That raises a tantalizing question: what's fueling these outbursts if not solar heating? Some scientists suspect hidden reservoirs of ice, buried deep beneath its rocky surface and occasionally punctured by micrometeoroid impacts. Others propose ice volcanoes, where pockets of frozen gases build pressure until they explosively decompress, sending dust jets arcing into space. Beyond its peculiar behavior, Elst-Pizarro holds profound clues about the early solar system. If it does contain ice, that challenges long-held assumptions about the asteroid belt's dryness, suggesting water might have been more widespread during the solar system's infancy than we thought. That, in turn, could rewrite theories about how water, and perhaps even the ingredients for life, were delivered to Earth. Some researchers go further, speculating that main belt comets like this one might have been cosmic water carriers, ferrying ice-rich material into the inner solar system during its chaotic formative years. Yet the mystery deepens when we consider how many more of these hybrid objects might be hiding in plain sight. Elst Pizarro was only the first. Since its discovery, a handful of other main belt comets have been identified, each with its own quirks. Could there be hundreds, even thousands more, masquerading as ordinary asteroids until they suddenly flare to life? The answer could reshape our understanding of the asteroid belt, revealing it not as a static graveyard of rocky debris, but as a dynamic, ice-rich frontier teeming with hidden activity. For astronomers, Elst Pizarro is more than just a curiosity. It's a living laboratory for solar system evolution. Every time it stirs from its slumber, it offers new data, new questions, and new possibilities about the origins of worlds. And as we piece together its secrets, one thing becomes clear: the solar system is far stranger, far more fluid than we ever imagined. The lines we draw between comets and asteroids, between the inner and outer solar system, might not be boundaries at all, just waypoints in an ongoing cosmic dance, one that we're only beginning to understand. In the vast cosmic tapestry where dark matter is supposed to be the invisible glue holding galaxies together, NGC 1052-DF2 stands as a defiant outlier, a galaxy that appears to play by its own rules. Discovered in 2018, this ethereal, ghostly structure, located 65 million light-years away in the constellation Cetus, has sent shockwaves through astrophysics by seemingly lacking the very ingredient scientists thought was essential for galactic survival: dark matter. This isn't just a curiosity, it's a direct challenge to one of cosmology's foundational pillars, forcing us to ask, what if we've been wrong about how galaxies form? At first glance, NGC 1052-DF2 looks like any other ultra-diffuse galaxy, a wispy, faint collection of stars so spread apart you could fly through it for light years without encountering anything substantial. But when astronomers measured the motion of its star clusters, they found something astonishing. The stars were moving far slower than expected, suggesting the galaxy's mass was almost entirely accounted for by visible matter alone. No dark matter halo, no invisible scaffolding, just stars drifting as if gravity itself had taken a break. This discovery was so counterintuitive that the scientific community initially reacted with skepticism, wondering if the measurements could be flawed or if some unseen force was at play. One leading alternative theory suggests the galaxy might have been stripped of its dark matter through violent cosmic encounters. Picture this: over billions of years, NGC 1052-DF2 could have been repeatedly grazed by a larger neighbor, its dark matter ripped away like cosmic theft, leaving behind only the stars too stubborn to be torn loose. Yet even this explanation has holes. The galaxy shows no obvious signs of distortion or tidal debris, no telltale scars of such a traumatic past. Another possibility is that we're seeing a rare case of a galaxy forming in an unusually empty pocket of space, where dark matter never pooled densely enough to dominate its structure. Then there's the most radical idea that dark matter isn't the universal force we thought. Some theorists propose modified gravity theories, like modified Newtonian dynamics, which tweak the equations of motion to explain galaxy rotation without invoking invisible matter. But these theories struggle to explain other cosmic phenomena where dark matter's fingerprints are undeniable, like the bullet cluster's gravitational lensing. The existence of NGC 1052-DF2 doesn't just challenge one galaxy's story, it forces us to reconsider whether dark matter is a one-size-fits-all solution or if the universe allows for exceptions we don't yet understand. What makes this galaxy so compelling isn't just its defiance of expectations, it's the questions it raises about the diversity of galactic evolution. If dark matter isn't always the architect of galaxies, what other invisible forces or peculiar histories might shape them? And if this outlier isn't alone, if more dark matter-deficient galaxies are lurking in the cosmic shadows, then our models of the universe might need more flexibility than we ever imagined. For now, NGC 1052-DF2 remains a luminous enigma, a reminder that even the most well-tested ideas in science must leave room for the unexpected. Whether it's a cosmic fluke or a sign of deeper mysteries, one thing is certain: the universe still has surprises up its sleeve. Most black holes we know of are cosmic heavyweights, collapsed stars so dense they warp spacetime itself into inescapable prisons of gravity. But nestled in the constellation Monoceros, just 1,500 light-years from Earth, lurks something far stranger. A black hole so small, so unassuming, it challenges our very definition of these cosmic monsters. Meet the unicorn, a black hole with a mass just 3 times that of our Sun, making it one of the smallest ever discovered. If most black holes are the universe's heavyweight champions, this one is a featherweight contender, and its existence might rewrite the rules of stellar death. The unicorn earned its name not just for its rarity, but for how it was found. Unlike typical black holes that announce themselves with blazing accretion disks or X-ray bursts, this one is utterly dark. Astronomers detected it indirectly by studying a nearby red giant star, which showed subtle but telltale distortions in its motion. Something invisible but massive was tugging at it, warping its orbit like an unseen puppeteer. After ruling out other possibilities, the only explanation left was a black hole, but one defying expectations. What makes the unicorn so revolutionary is its size. Black holes are generally divided into 2 categories: stellar mass black holes, born from collapsing stars at least 20 times the Sun's mass, and supermassive black holes, lurking in galactic centers with millions or billions of solar masses. The unicorn falls into a mysterious gap between the smallest known black holes and the largest neutron stars. Ultra-dense stellar corpses typically no heavier than 2.5 solar masses. For decades, scientists debated whether objects in this mass gap could even exist. Some theories suggested physics would prevent stars from collapsing into anything between a neutron star and a black hole. The unicorn proves otherwise. This raises a tantalizing question: is the unicorn a missing link in stellar evolution? One theory suggests it could be the remnant of a neutron star that gradually pulled in extra mass from a companion until it tipped over the edge, collapsing into a black hole without the usual supernova fanfare. Alternatively, it might be the product of 2 neutron stars merging, a phenomenon observed in gravitational wave detections, but never before seen producing such a small black hole. Either scenario would mean these tiny black holes are far more common than we thought, hiding in plain sight across the galaxy. The implications stretch beyond classification. If the unicorn is a stripped-down black hole, it could explain why we've struggled to find others like it. Without the violent aftermath of a supernova or the flashy accretion disks of larger black holes, these objects might be nearly invisible, detectable only through their gravitational whispers. That makes them cosmic ghosts, ubiquitous yet elusive, quietly shaping the galaxy in ways we're only beginning to grasp. But the biggest mystery isn't just how the unicorn formed, it's what happens inside. The smaller a black hole, the more extreme its gravitational gradient near the event horizon. At just 3 solar masses, the unicorn's gravity would stretch and compress matter in ways even its massive cousins can't match. Some physicists speculate that tiny black holes like this might be laboratories for quantum gravity, offering clues about how general relativity and quantum mechanics reconcile at the smallest scales. For now, the unicorn remains an enigma, a cosmic David among Goliaths, quietly upturning assumptions about how stars live and die. Its discovery hints at a hidden population of overlooked black holes, each with stories to tell about the universe's most violent transformations. And as we peer deeper into the darkness, one thing becomes clear: sometimes the smallest things shine the brightest light on the universe's deepest secrets. The cosmic microwave background, the faint afterglow of the Big Bang, should be the most uniform thing in the universe, a nearly perfect snapshot of the infant cosmos. But in 2004, astronomers scanning this ancient light stumbled upon something impossible: a sprawling void roughly 1.8 billion light-years across, colder than its surroundings by a fraction of a degree. Dubbed the cold spot, this anomaly isn't just a curiosity, it's a cosmic bruise so vast it could swallow thousands of galaxies whole, and the most unsettling explanation. It might be the imprint of a collision with another universe. At first glance, temperature variations in the CMB aren't unusual. Tiny fluctuations are expected, echoes of quantum ripples stretched across the cosmos by inflation. But the cold spot isn't just another ripple, it's a staggering departure from the norm, with odds of occurring naturally estimated at less than 2%. Imagine throwing a handful of confetti into the air and watching every piece land in the exact same spot. That's the level of statistical unlikelihood we're dealing with here. Theories attempting to explain it range from the mundane to the mind-bending. Some suggest it could be a supervoid, an enormous region of space with fewer galaxies and less matter, causing light passing through to lose energy and appear cooler, a phenomenon known as the integrated Sachs-Wolf effect. But even the largest known voids don't come close to the cold spot scale, leaving this explanation on shaky ground. Then there's the more radical idea that the cold spot is a cosmic scar from a collision with a parallel universe. In the multiverse theory, our universe isn't alone. It's one bubble in an infinite foam of others, each with its own physical laws. If another bubble grazed ours during the universe's infancy, the energy released could have left behind a cold patch like a fingerprint on glass. The math is compelling. Simulations show such collisions would create disk-shaped temperature anomalies, eerily similar to the cold spot's profile, but proving it is another matter. Without direct evidence of the other universe's existence, the idea remains speculative, a tantalizing what-if hovering at the edge of science. Skeptics argue there's a simpler answer. The cold spot might just be a statistical fluke, a cosmic roll of the dice that had to land somewhere. After all, with a universe as vast as ours, even the most improbable events might occur purely by chance. Others propose exotic physics, like defects in space-time or primordial magnetic fields, as potential culprits. Yet none of these fully account for the cold spot's sheer size or its peculiar texture, an absence of smaller temperature fluctuations within it, as if someone had smoothed it out with a celestial iron. What makes this mystery so captivating isn't just the wild theories it inspires, it's the way it forces us to confront the limits of our knowledge. The cold spot exists at the intersection of cosmology and philosophy, a puzzle where the tools of science strain against questions that might never have definitive answers. Is it a window into the multiverse, a flaw in our models, or simply the universe reminding us that it still holds cards close to its chest? For now, it remains one of cosmology's great open questions, a patch of cold light whispering secrets we're only beginning to decipher. And as we peer deeper into that cosmic chill, one thing is certain: the universe is far stranger, far more mysterious than we ever dared to dream. Drifting alone through the icy darkness of interstellar space, CFB Sir 2149-0403 is a cosmic rebel. A planet without a sun, untethered from any star, yet glowing with eerie auroras that dance across its skies. Unlike the planets in our solar system, this rogue world doesn't orbit a parent star. It wanders freely through the galaxy, a silent nomad in the void. What makes it even more remarkable are the shimmering auroras that ripple across its atmosphere, powered not by a star's solar wind, but by something far more mysterious. This isn't just a curiosity, it's a glimpse into a hidden population of worlds that defy the very definition of what a planet should be. Rogue planets like this one are thought to form in one of two ways. Some are castaways, born in the swirling disks of dust and gas around young stars, only to be violently ejected by gravitational chaos, flung into the abyss by planetary sibling rivalry or passing stars. Others might form like stars themselves, collapsing directly from isolated gas clouds too small to ignite nuclear fusion, leaving behind dark, planet-sized orphans. CFBD SIR 2149-0403 appears to be one of these lone wolves, a world that never knew the warmth of a sun. Yet despite its frigid existence, it's far from inert. The auroras that illuminate its atmosphere are the key to its strangeness. On Earth, auroras are created when charged particles from the sun collide with our magnetic field, painting the sky with ribbons of light. But this rogue planet has no star to bombard it with solar wind. Instead, its auroras might be driven by its own internal dynamo, a churning core generating a powerful magnetic field that interacts with traces of ionized gas in interstellar space. Alternatively, some scientists speculate that tiny, unseen moons could be orbiting the planet, their gravitational tides stirring its interior and creating electrical currents that spark the otherworldly light show. But here's the most tantalizing possibility. Rogue planets like this might be hidden oases for life. Cut off from starlight, their surfaces would be frozen wastelands, but beneath thick layers of ice, tidal heating or radioactive decay could maintain vast subsurface oceans, liquid water sheltered from the cold of space, much like the hidden seas of Jupiter's moon Europa. Without a star's harmful radiation, these dark oceans could be stable for billions of years, offering a sanctuary for microbial life or even more complex organisms. Some astronomers hypothesize that rogue planets could outnumber stars in the Milky Way, meaning the galaxy might be teeming with such stealthy, life-harboring worlds drifting unseen through the darkness. The discovery of CFBD SIR 2149-0403 forces us to rethink the boundaries of habitability. Life as we know it thrives on sunlight and warmth, but in the infinite variety of the cosmos, life might find a way in the most unexpected places, even on a frozen world wandering forever between the stars. As we uncover more of these rogue planets, each one whispers the same haunting question: are we alone in the universe, or is life far more adaptable, far more widespread than we ever dared to imagine? Somewhere in the depths of intergalactic space, an invisible leviathan tugs at our entire galaxy with irresistible force, the Great Attractor, a gravitational anomaly so powerful it's dragging the Milky Way and thousands of other galaxies toward it at 14 million miles per hour. This cosmic juggernaut sits about 250 million light-years away in the constellation Norma, bending the trajectories of entire galaxy clusters like a celestial puppeteer. Yet despite its overwhelming influence, we know shockingly little about it. Why? Because it lurks directly behind one of the most frustrating blind spots in astronomy, the zone of avoidance. This mysterious region is the Milky Way's own doing. Our galaxy's dense central bulge, packed with stars, gas, and dust, blocks nearly all visible light from objects beyond it, creating a vast obscuring band that astronomers poetically call the zone of avoidance. Trying to observe the Great Attractor through it is like studying a lighthouse through a blizzard, possible, but maddeningly incomplete. For decades, this cosmic curtain left scientists guessing about the true nature of the anomaly pulling us toward it. Early theories ranged from a colossal supercluster of galaxies to an unimaginably massive black hole, or even a flaw in our understanding of gravity itself. Then came the game-changer, infrared and radio telescopes. Unlike optical light, these wavelengths can pierce through the Milky Way's obscuring veil, revealing glimpses of what lies beyond. Slowly, painstakingly, astronomers mapped the hidden structures behind the zone of avoidance, and what they found was both clarifying and confounding. The Great Attractor isn't a single monstrous object, but a sprawling concentration of mass known as the Norma Cluster, a galactic metropolis containing thousands of galaxies, all bound together by gravity. Yet even this enormous cluster couldn't fully account for the staggering gravitational pull we're experiencing. The real twist, the Norma Cluster itself seems to be caught in the grip of something far larger. The Laniakea supercluster, an unfathomably vast web of galaxies spanning 500 million light-years. Within this hierarchy, the Great Attractor is merely a local overdensity, a gravitational waypoint in an even grander cosmic flow. Picture a leaf caught in a river's current, drifting not just toward a single rock but pulled along by the entire watershed. That's our place in this celestial dance, drawn toward the Great Attractor, which in turn is being hauled toward the even more massive Shapley supercluster, the largest known concentration of matter in the observable universe. But the mystery doesn't end there. Recent observations suggest dark energy, the mysterious force accelerating the universe's expansion, might be warping the Great Attractor's influence on cosmic scales, complicating our measurements. Some researchers even speculate that undiscovered structures hidden deeper in the zone of avoidance could be contributing to the anomaly. Every breakthrough peels back another layer, revealing not just answers but new questions about the forces sculpting our corner of the cosmos. The Great Attractor stands as a humbling reminder of how much lies beyond our sight. It's a cosmic paradox, an invisible hand shaping the motion of galaxies, yet so obscured by our own galaxy's brilliance that we're left piecing together its secrets one wavelength at a time. As technology advances and new telescopes probe deeper into the zone of avoidance, one thing is certain: the universe's greatest mysteries often lie not in the distant void, but just beyond the shadows we cast ourselves. In the constellation Hercules, a star named TUIC 2597-735-1 hides a secret, a shimmering, ultraviolet halo known as the Blue Ring Nebula. Unlike most nebulae which glow with the soft hues of ionized gas, this one blazes in invisible ultraviolet light, its true colors revealed only through specialized telescopes. But its brilliance isn't just a cosmic light show. It's the aftermath of a stellar crime scene, the remnants of two stars that collided and merged in a violent embrace. What makes this nebula so extraordinary isn't just its origin, but the fleeting, transient nature of the evidence it leaves behind, offering astronomers a rare glimpse into one of the universe's most chaotic and poorly understood events. The Blue Ring Nebula's story begins with a pair of stars locked in a gravitational dance, spiraling closer over millennia until they finally crashed together. Most stellar mergers are messy affairs, flinging debris in all directions and leaving behind a single, scrambled star. But this one was different. Instead of a chaotic explosion, the collision ejected two cone-shaped jets of material, each racing outward at staggering speeds. Over time, these jets expanded and cooled, forming a hollow, ring-like structure that now glows in ultraviolet light due to the intense radiation from the merged star at its heart. The result, a celestial bullseye, a perfect snapshot of a cosmic merger frozen in time. What's even more fascinating are the nebula's bizarre chemical fingerprints. Spectroscopic analysis reveals an odd absence of hydrogen, the universe's most abundant element, replaced instead by helium and traces of heavier elements like nitrogen. This peculiar composition suggests the merger tore apart the star's outer layers, exposing their helium-rich cores to space. Adding to the enigma, the nebula contains molecules like carbon monoxide and formaldehyde compounds typically found in the frigid depths of interstellar clouds, not the aftermath of a violent stellar collision. It's as if the universe took two stars, smashed them together, and left behind a chemical puzzle that defies every expectation. But the most haunting aspect of the Blue Ring Nebula is its impermanence. Unlike planetary nebulae, which linger for tens of thousands of years, this structure is dissolving before our eyes. The ultraviolet glow, caused by shocked hydrogen molecules being ripped apart by the central star's radiation, will fade within a few thousand years, leaving no visible trace of the cataclysm that created it. That makes this nebula a cosmic mayfly, a fleeting phenomenon that astronomers were lucky to catch in the act. Had we looked even a few millennia earlier or later, we might have missed it entirely. The implications ripple far beyond this one celestial oddity. If mergers like this are common, they could explain other mysterious ultraviolet sources scattered across the galaxy, stellar ghosts hiding in plain sight. They might also shed light on the origins of blue stragglers, stars that appear inexplicably young in ancient star clusters, possibly rejuvenated by similar collisions. And for planetary systems orbiting these stars, the consequences would be apocalyptic. Any nearby worlds would be vaporized or flung into the void, a sobering reminder of how violent the universe can be. Yet the Blue Ring Nebula's greatest gift is the way it forces us to rethink stellar evolution. We've long assumed stars live solitary lives, aging quietly until they exhaust their fuel. But this discovery reveals a hidden chapter, one where stars collide, merge, and rewrite their destinies in explosions of light and gas. It's a reminder that even in the vastness of space, no star is truly alone, and the universe's most dramatic stories often unfold in the shadows, waiting for the right moment to blaze into view. In a universe where quasars, the blazing cores of distant galaxies powered by supermassive black holes, are typically scattered like lonely lighthouses across the cosmos, astronomers recently stumbled upon an impossible trio. Nestled within the constellation Leo Minor, three of these cosmic powerhouses orbit one another in unthinkable proximity, separated by distances smaller than the span of our own Milky Way. The odds of finding such a cluster are so astronomically low, scientists initially questioned whether their telescopes were playing tricks on them. Either we're witnessing a 1 in a billion cosmic fluke, or the universe is hiding a secret about how these titanic structures grow and interact. The first hurdle in understanding this trio is wrapping your mind around the sheer improbability of their existence. Quasars are rare to begin with, brief, ultra-bright phases in a galaxy's life when its central black hole feasts on surrounding gas, outshining entire galaxies. For two quasars to form side by side is already a cosmic lottery win. But three, the chance is so minuscule, it's like finding three needles in a galactic haystack, not just touching but threaded together. One theory suggests we're seeing a gravitational mirage, a trick of light where a single quasar's image is warped and multiplied by the bending of space-time around an intervening galaxy, creating illusory duplicates. Yet detailed observations reveal subtle differences in the quasar's light signatures, making this explanation shaky at best. If the trio is real, its existence could rewrite our understanding of galactic evolution. Supermassive black holes are thought to grow by merging, with galaxies colliding over billions of years. But for three quasars to ignite simultaneously in such tight quarters implies a frenzy of galactic collisions happening on timescales far shorter than models predict. Some astronomers speculate this might be a snapshot of the universe's most extreme environments, a galactic nursery where clusters form in overdrive, funneled together by the gravitational pull of invisible dark matter filaments. Others propose these quasars might be relics from an era when the universe was smaller and denser, their light only now reaching us after billions of years. The implications stretch beyond mere curiosity. If such tight quasar groupings are possible, they could explain enigmatic flashes of energy detected across the cosmos, previously attributed to isolated events. They might also hint at undiscovered physics governing black hole interactions, where proximity doesn't always lead to catastrophic mergers, but instead creates stable, if temporary, configurations. And if dark matter is indeed herding galaxies into these unlikely clusters, it could reveal clues about the invisible scaffolding shaping the universe's large-scale structure. Yet the most tantalizing question remains, are we seeing a cosmic anomaly or just the tip of an iceberg? With new telescopes like the James Webb Space Telescope peering deeper into the infrared, astronomers may soon uncover more of these improbable groupings, each one a puzzle piece in understanding how the universe's most violent objects coexist. Whether mirage or reality, this trio challenges us to rethink the rules of cosmic crowdedness, proving once again that the universe thrives on defying expectations. From the eerie silence of the Boötes Void to the violent beauty of merging quasars, these 30 cosmic wonders aren't just oddities, they're glimpses into the universe's boundless creativity. Each one defies expectations, from rogue planets glowing with alien auroras to galaxies that somehow exist without dark matter. They remind us that for every rule we think we've uncovered, the cosmos has a way of rewriting the script. What's truly humbling isn't just their strangeness, but what they reveal about how much we don't know. The universe isn't just stranger than we imagine, it's stranger than we can imagine. Consider how these discoveries tear at the fabric of our understanding. A star older than the universe, a black hole small enough to fit between the pages of a science textbook. Structures so vast they shouldn't exist. These aren't just trivia, they're cosmic breadcrumbs leading us toward questions we haven't even thought to ask yet. And that's the thrill of it all. Every anomaly is a crack in our models, an invitation to dig deeper, to rethink what's possible. But here's the most exciting part. This list is just the beginning. For every mystery we've solved, a dozen more lurk in the shadows. What's hiding in the uncharted depths of the zone of avoidance? Are there more rogue planets with subterranean oceans? Could the cold spot really be a bruise from a parallel universe? The universe isn't done surprising us, not by a long shot. So now it's your turn. Which of these cosmic wonders left you staring at the screen, questioning everything? Or better yet, what undiscovered anomaly do you think might be out there, waiting to shatter our theories all over again? Drop your thoughts in the comments, because the greatest thing about space isn't just its mysteries, it's the way they bring us together, sparking conversations that stretch from your screen to the stars and back. And who knows, the next jaw-dropping discovery might just start with an idea whispered right here. After all, the universe's strangest secrets belong to everyone, so let's keep searching, keep wondering, and keep pushing the boundaries of the unknown. The cosmos is listening.